All right, welcome to video 12-4C. This is the last of your 3 videos for tonight. If you've made it this far, you're persevering really well, you guys. It's a lot of new stuff in one sitting, so keep it up. All right, explain 4. We're going to be proving the Pythagorean theorem by using these similar triangles. You say Pythagorean theorem is just the Pythagorean theorem. It's a squared plus b squared equals c squared. I've known it all my geometric life. Yes, true, but it actually does come from similarity, and we're going to talk through that right now. So in example 4, we're given right triangle ABC, and so we are being asked to prove the Pythagorean theorem. The first step that they ask us to do is to draw an altitude to the hypotenuse. Now, we just got done working with that on the previous page, so that should come as no surprise here, that's our XC. And so what we can say is that angle BXC is equal to angle BCA, and that's just simply because all right angles are congruent. Angle B right here is going to equal angle B again because simply of the reflexive property. And so triangle BXC is similar to BCA. Now again, that's this right triangle here, the medium-sized triangle, if you will, to triangle BCA, the big one, because we've got 2 angles that are congruent, so that's angle-angle similarity theorem. In the same way, angle AXC and angle ACB are congruent again because we have all right angles being congruent, and angle A is congruent to itself with our reflexive property again. And so therefore, angle-angle similarity is leading us to another pair of similar triangles within that setup. Hopefully that's just kind of showing you the small, medium, and large that you wrote down from before. So now what we're going to do is we're going to go ahead and in part 2 they're going to label the segments of the hypotenuse as D and E as shown over here. So here's D and E, and so they're breaking up this whole length C into those pieces. Now we're going to use the fact that corresponding sides of similar triangles are proportional to write proportions, and if you want you can draw your small, medium, and large triangles here again, but the first proportion is that A to C, so let's look at that long leg here, A to whole entire hypotenuse C, is going to equal something to A. So we're going, it looks like, from the large triangle A to C, the long leg of the medium triangle, where A is the hypotenuse, which is why it's in the denominator there. The long leg of the medium triangle is E, so we'll put that in the top. Then proportion 2, and this is going from our small triangle to our large triangle, says that, or sorry, the other way around, B to C is going to be the sides of B, short leg, to hypotenuse, and then in the small triangle, the short leg is D to the hypotenuse B. So we're going to fill in D there. Now we're going to keep those proportions in mind, and on the next page we're going to just use some algebra. Multiply both sides by AC, or cross multiply is the other way of thinking about that. We're going to say A squared on that first proportion is equal to EC, and B squared is equal to DC. If we add those two equations together, we get that A squared plus B squared on the left-hand side, just adding kind of down the columns there, is going to equal EC plus DC. And then it says factor the right-hand side, that's this side right here. A common factor exists of C, so we'll leave A squared plus B squared alone. Factor out our common factor of C, and we're left with E plus D. Well, finally, we're going to use the fact that E and D are the parts of that whole entire big triangle's hypotenuse, which is just C itself. And so if all of this becomes just C, then look at that. We are at A squared plus B squared equals C squared. So there aren't any your turns for this video, but be prepared to try and duplicate this proof a couple times over with a practice worksheet in the next class. And we'll see you later.